Please refer to question number 7 in the question set. We have, the question is slightly modified. The same question is given as a carboxylic group here, but it is not written here as a carboxylic group. The question has been modified. Instead of a carboxylic group, we have an alcohol. That is C6H5 3 times C. Instead of COOH, we have a CH2OH. What will happen when it is treated with hydrogen and treated further with methanol? That will be another way of looking at the question. So when you look at that question, we find that normally OH, as we know, is a very poor leaving group. So in order to make that as a good leaving group, this OH is converted, treated with acid to give rise to water. So then the first step will be, when it is treated with acid, it will give rise to C6H5 3 times C, CH2, it will become OH2 plus. Instead of the OH here, one proton will be added. Now we have a bond here. That bond gets broken. So we have the loss of water molecule. So what we get will be C6H5 3 times. I am writing it separately so that one of the groups is going to migrate. We have this cation. We all know among the cations, this primary cation is less stable. Therefore, this leads to a 1,2 shift of a phenyl group. A C6H5 migrate. There are 3 phenyl groups available here. One of them migrates. So what will be the resulting structure? Let us migrate this group. We will also see there, it is not simply the shift of a C6H5, it is C6H5 minus, it goes to the pair of electrons, so that neutralizes the positive charge. So what we get will be C6H5, C, C6H5, one of these groups have already migrated, which has resulted in a cation. Then CH2, C6H5. What is the difference between these two structures? In this structure, it remains as a primary carbocation, whereas in this structure, since one methyl phenyl group has migrated to this, this has become cation, but it is a tertiary carbocation which is more stable. Immediately, methanol gets attached to it. Methanol is a nucleophile. We have the nucleophilic attack by the methanol. Methanol gets attached to this to form the methyl ether C6H5, C, C6H5, O, CH3, H. There will be a plus. Then CH2, C6H5. As you know, this plus charge, when it loses the proton, finally this will give rise to this compound. This is actually, the final step will be the loss of a proton. But it is very easy because it has got a positive charge. When it loses the proton, this positive charge will also be removed, and then finally this is exactly the compound what we have written in this. So the question has been slightly modified. Question number 7 has been modified. For the COOH group, we have the CH2 group which involves the migration also. This is something similar to the neopentyl system which you are seeing. Supposing all the 3 are methyl groups and we have some, this is referred as a neopentyl system. That is something similar to these 3 methyl groups plus this. This is known as a neopentyl cation. Neopentyl cation is very unstable. Therefore, normally one methyl group migrates to the other position. Similarly, in this case, a phenyl group migrates instead of the methyl group.